Hey, we're gonna do part 2 now, my friends. So I know the video stopped pretty harshly, but we're looking at writing each of these expressions in the exponential form. So whenever we have roots, we can always split them up with multiplication. So this is the same thing as the root of 25 times the root of a to the 6, or the square root. And we know that 25 is actually a perfect square because 5 times 5 gets us 25. So this is 5 times an a that has a power of 6 and a root of 2. Here's our power of 6. Remember, when we don't see a number 2 outside, there's like an imaginary 2 there. And we can actually simplify this further to say 5 times a to the 3rd, because 6 divided by 2 gets us 3. Okay. And when you're all set and you have everything that you need here, push ahead to slide 11. Remember, you can pause the video at any point, whatever you need. And slide 11, we are just still writing and practicing with this equivalent form of going back and forth between our rational exponent and our radical form. Exponent form, radical form. So for the first one, our base is a. So I'm going to bring that a. And then I'm going to draw my root symbol. And notice that the power is 3 and the root is 2. So I'm not going to put a little 2 outside. It would go right here, but again, when it's a square root, we don't put the 2 outside. It's just like the most natural form. So here's that answer right there. For the next one, our base, again, is a. And then I'm going to draw my root symbol. Our power is 5. Oops, sorry. Our power is 2 on top. And our root is 5. Every time we're doing this, we're doing power over root. That's how we're writing our rational exponent, power over root. So on the bottom, we're given the exponential form, and we want to write it as a radical, and write it as these words are backwards. We're given it in radical form and we want it in exponential form. So our base is a. Our power is 1. It's an a to the 1st. And our root is 2. So this is an a to the 1/2. 1 and 2. When the power is 1, we're not going to see that little 1. And when the root is 2, we're not going to see that little 2. That's the only time when that happens. That's when we see them as like imaginary. So that's something important to notice for your notes. For the next one, we have our base of a. Our power, again, is 1. There's only one a. And our root is 5. So this is an a to the 1/5. Last one here, our base is a. Our power is 5. And our root is 3. So it's an a to the 5/3. Beautiful. Slide 12 when you're ready. Another thing that we can do when we're simplifying our roots is we can always simplify our radical form. And the way that we do that is by pulling out any perfect squares. Okay? So on the right-hand side, notice I put our first 10 perfect squares, so they are there and ready for you if you need to use them. So I see, first of all, this number 18. 18 is not a perfect square, so we want to look at numbers that are smaller than 18 that maybe multiply to 18. And that makes me look at the number 9. Because I know that 18 is 9 times 2. So we can split this up as the square root of 9 times the square root of 2. The square root of 9 is just 3. So this simplified answer is 3 square roots of 2. There's no more simplifying we can do with that root 2, so we leave it as is. For the next one, for the square root of 50, 50 is not a perfect square, so I look for numbers that are smaller than 50 that multiply to 50, and I see 25. 25 times 2 gets us 50. So the square root of 50 is the same as the square root of 25 times the square root of 2. Square root of 25 is 5 root 2. Again, we can't simplify that root 2, so we leave it as is. Push to slide 13 when you're ready. We're going to do 2 more like this. We have the square root of 300a squared. 300 is not a perfect square, but the number 100 goes into it. So this is really the square root of 100 times the square root of 3. And then we also have this square root of a squared. The square root of 100 is 10, because 10 times 10 is 100. We leave the square root of 3 as is. And the square root of a squared, because that power and root are the same, they cancel each other out, and we're just left with a. So we would write this as 10a times the square root of 3. For the next one, we have the square root of 490 times a to the 6th. So that's the square root of 490, which is 49 times 10. That gets us 490, and 49 is a perfect square. So that's a helpful number to pull out. And then we have the square root of a to the 6th. The square root of 49 is 7. The square root of 10 cannot be simplified any further, so it just stays as the square root of 10. And a to the 6th, this is an a to the, remember, power over root. So our power is 6, our root is 2. So we can simplify that completely as an a to the 3rd power, because 6 divided by 2 is 3. So again, here's our power. That was our power of 6, and our root is a 2 in the front. Push ahead to slide 14 when you are all set. Beautiful work, everyone. So this next one says, evaluate each expression shown in the table and to use your Desmos calculator. So getting nice and comfy with that calculator. We can hit 25, and then I'm going to hit this A to the B button to raise it to the 3/2 power. So that means the power is 3, the root is 2, and our answer is 125. Right? This is the same thing as root of 2, 25, not squared, to the 3rd power. Right? There's the rational exponent form, and there's our radical form. Either way gets us that solution of 125. In parentheses, I'm putting negative 64, and then I'm raising it to the 2/3 power, and I end up with 16. Make sure you're practicing typing this into your calculator as well. Then we have 27, and we're going to raise that to the 2/3. And when we do that, we get a number 9. I'm matching exactly how it's written. So if I see parentheses, I am putting parentheses into my calculator. So we have a 16 to the 3/4, which gets us a value of 8. And then finally, we have a negative 16 to the 3/2 power, which gets us a negative 64. Notice that negative was not in parentheses, so we did not put it in parentheses when we typed it into the calculator. And then when you're all set, push to slide 15. So we're going to rewrite these in, it says rewrite each radical as an expression with a rational exponent and then simplify. So As always, I'm reminding myself, maybe I'm writing this on my notes again, the more you write it, the more it gets into your brain. Power over root, right? So our base here is x, our power is 10, and our root is 2. 10 divided by 2 gets us 5, so this is really an x to the 5th. For the next one, we have the square root of 25, and we can pull that apart and multiply it by the square root of a to the 6th. The square root of 25 is just 5, and the square root of a to the 6th is an a to the 6 over 2. Our power is 6, our root is 2. 6 divided by 2 gets us 3, so it's a 5a cubed. The last one on this slide is the square root of 18, a to the 6th, b to the 9th. I like to just split this up. It helps my brain look at them in 3 different pieces than all at once. If you're fine with looking at it all at once, then you, do whatever feels best. That's totally fine. The square root of 18. 18 is not a perfect square, so we could split this up using our perfect square of 9. And 9 times 2 gets us 18. This piece here, we can rewrite as a power of 6 and a root of 2. So it's an a to the 6 halves. And here we have a b to a power of 9 and a root of 2. Further simplifying, the square root of 9 is 3. Square roots of 2. A to the 6 halves becomes an a cubed, and that stays as a b to the 9 halves. 9 divided by 2. We don't want to write a decimal in the exponent, so we can just leave it as a 9 divided by 2. And we have one final practice slide, slide 16, when you're ready, which says evaluate the expression 81 to the 1/2 minus 81 to the 1/3 plus 100 to the 1/2. So 81 to the 1/2, if we think and remind ourselves that all this is telling us is its power and its root. So this is a square root of 81 to the first power minus a cube root of 81 to the first power plus a square root of 100 to the first power. Well, the square root of 81 is just 9. The cube root of 81, maybe we go into our calculator and we say, what's the cube root of 81? And that is a mess. Oh, a cube root of 8, not 81. Hold on, that makes sense. I wrote it wrong. It's supposed to be an 8 there because right here, it's an 8 to the 1/3. So the cube root of 8, maybe you remember that from your perfect cubes, is the number 2. Because 2 times 2 times 2 gets us 8. And then we're going to add the square root of 100, which is 10. 2 plus 10 in parentheses, simplifying that first, gets us 12. And 9 minus 12 is a -3. Beautiful. So that is all the practice notes. On slide 17, you're doing a reflecting on how you're feeling about this. And on slide 18, you're going to write a little dear student to tell them what we learned, one thing that you learned and you want to remember from this lesson, okay? Make sure when you're doing the assignments, my friends, that you're continuing to watch the videos and getting everything that you need. And if you need further support from me, you can always send me a message and reach out to me, okay? Really nice job today, everyone. Take care, and I'll see you soon.